Hello friends, here I am going to discuss about the K-map of the digital electronics. Okay, so what is the K-map? What is the importance of the K-map? Okay, the K-map is the full form of the K-map is the Carnot map. So when we will use the K-map, so if we want to reduce the expression, logical expression. So normally we follow the different kinds of the Boolean properties to reduce any logical expression. Right. So last class I discussed about the SOP and POS. Okay. So in case of the SOP and POS, if you find SOP means sum of product and POS is the product of sum. Okay. So if you get any kind of the SOP or POS, so you will get 4 or 5 terms in SOP and POS. Right. So but you have to minimize. So if you want to design any circuit, rather use of the more number of circuit, you have to use the less number of circuits. So for that you have to minimize the SOP expression or POS expression. Okay, so for minimizing SOP and POS expression, you have to follow some Boolean properties. But in case of the KMF, it is not mandatory to follow the Boolean properties. Okay, so there is there are set of protocols for KMF. We have to follow those set of protocols for minimizing the Boolean expression using KMF. Okay, so first I will tell what is the structure for KMF. Normally and maximum time we used to follow two variable inputs or three variable inputs and four variables like AB inputs, ABC inputs and the ABCD inputs, right? So for two variables and for three variables and four variables there are the different K map we have to follow, right? So if we have the two input A and B inputs, right? You have two inputs. For that normally if we have two inputs, how many combinations we can write? Two input, right? 2 to the power 2, that is 4 combination we can write. Okay, so when we design the K-map by using the 4 combinations, so that means it is 2 to the power n, right? N is the number of input. So in K-map I have to draw the K-map. It is one kind of the box. In this box you have to put the number of cells. Okay, how many cells are required? So for K-map 2 to the power n number of cells are required. Okay, so map is one kind of the map. We have to do the mapping, right? So so 4 cells. How can you divide? In this way we can get the 4 cell. Okay, so here A and B two inputs are there. So I am putting A here and B here. Okay. Now for A, if A is a single input, you have the two distinct numbers, right? 0 and 1. You have two distinct numbers 0 and 1. For B also you have two distinct numbers. So if you remember the SOP and POS, if you want to get SOP and POS expression from the truth table, so for that, this is about the SOP. Okay, this is about this. I am designing KMF for SOP. So SOP means sum of products. Suppose we have one kind of the expression A, B, C prime, A, B, C. So this is the SOP. Okay, sum of product. If we have the SOP product, how can you implement the expression by using the K-map? So for SOP, I am writing the K-map. Okay, so if you have A and B, so how many cells? 4 cells are required. So here I am putting 0, 1. So you can also write as A prime A. So 0 means A prime, 1 means A. Here also you can write as a B prime B. Okay. So I am numbering these cells. Okay. So here how can you number? This is 0, this is 0. So this is 0, 0 means 0. A is 0, B is 1, 0, 1, right? 0, 1 means 1. 1, 0, it is 2. This is 1 and corresponding to this cell, this value is 1, this value is 1. So this is 3. So in this way we can number the cell. Okay. Now for 3 variable input. Okay. So how many combinations? 2 to the power 8? 8 combinations. So for 3 variable inputs, in KMap 8 cells are there. Okay. So how can you design the 8 cells? In this way we can design 8 cells. So A I am putting here, B I am putting, BC I am putting here. So here also write as A prime A or 0, 1. Here also B prime, C prime, B prime C, BC and B C prime. Means it is 0 0 0 1 1 1 1 0. Normally in to if we write the truth table for, because for BC two inputs means how many combinations? Four combinations are there. Okay, but if you write the truth table, so after 0 1 you will get 1 0. But here I am writing 1 1. Okay, that means, so when you go from one cell to another cell, there is a one single bit change. Okay, no double bit change should be there. Okay, that's why if you put 1 0 here, so you can see 0 is also will be changed and 1 will be also changed. So I have to put 1 1 here. The QMAP is designed in such a way. Okay, so I am numbering. You can remember. So A prime B prime C. So 0 0 0. It is 0. This is 0. This value is 0 0 0 0. 0 1 2 3. Why this 2 here? Because you can see this value is 0, this value is 1 0. 0 1 0 is 2. This value is 0, this value is 1 1. Okay, 3. In this way you can number. Okay, 0 1 2 3 4 5 6 7. Now come to the 4 inputs are there. So for 4 inputs, how many combinations? 16 combinations. That means 16 cells in KMF. Okay, 16 cells are there. Here AB, here C. See here I have to write 4 combinations: A prime, B prime, A prime B, A B, A B prime. That means 0 0 0 1 1 1 1 0. Okay, here also C prime D prime, C prime D, C D, C D prime. 0 0 0 1 1 1 1 0. Okay. Now in the same phenomena I can number the cells: 0 1 2 3 4 5 6 7. Here it will be 8 because it is 1 1 array. Here 1 0. That's why it is 8. 8 9 10 11 12 13 14 15. Okay. How it is 9 here? You can see this value is 1 0. This value is 0 0. Okay. So 1 0 0 it is 9 cell. Okay. So these are the three kinds of the cells for different input variables. Okay. Now how can you minimize the expression by using this schema? So I am explaining SOP. Okay. So this, suppose we have this question. Okay. So I am doing for first this one. Okay. So here you can see this is means 1 1 0. This is means 1 1 1. Or you have this is also. This is means 0 0 1. If you convert this thing into, because A B means 1 1, like this way I have written. If you convert into binary, this is 1 1 4 to 6. This is 7. This is 1. Okay. So from the function, or the function will be like this way, mean term. Okay, 1 6 7. Okay, so you have this question or this question. Okay, so if you have this question, so you have to convert it into this format. How many, which cells represent 6 7 1? That means in function I have these three combinations. Okay, in function I have these three mean terms, right? So that means I have to put logic 1 in those cells. If you have to check the cell number 1 6 7, okay, I have to put logic 1 in those cells. Okay, I am again doing this one. Okay, A B C, B prime C prime, B C prime, B C, sorry, B prime C, this is B C prime. Okay, A prime A. 0 1 2 3 4 5 6 7. Okay, so here you can see this 6 7 1. That means, or 1 6 7. That means I have to put logic 1 in those cells. Okay, this is the first procedure. If you have any expression either in mean term or in the logical expression, first you, from the logical expression you have to get the mean terms. Or if mean term is there, then it is fine. Okay, so from the mean terms I have to understand that I have logic 1 in those mean terms. Okay, so I am putting logic 1 in those cells. After that, I have to do the grouping. Okay, so here I am drawing how, what are the rules for grouping. Okay, so first maximum 4 variable we can draw, right? So how can you do the grouping? So that means here, okay, suppose you have such kind of the outputs. Okay, grouping should be done between adjacent one. Okay, grouping should be done between adjacent one. Okay, first. Second is the maximum quad, maximum, then octal, then pair. What means? So I have to choose the so I have to choose adjacent one. Okay, for grouping I have to choose adjacent one. Okay, after choosing adjacent one, I have to check how the structure look like. Okay, so first I have to check the maximum quad. So whether I can design a maximum quad by those adjacent one or not. Okay, first I have to check from this schema whether I can design maximum quad by using those adjacent one. Okay, after that I have to sorry, first is this one, octal. Okay, then quad, then pair. After octal, you have to check the quad. Okay, maximum, first you have to check maximum whether I can design octal by using, octal means 8 ones. Okay, whether I can design 8 octal by using those adjacent one or not. Next is that I have to check quad is possible or not. That means quad should be designed by all 4 adjacent one. Okay, next is the pair is possible or not, adjacent to 1. Okay, if you have a one separate one, that will also create as an individual group. Okay, this is a will create as an individual group. Suppose I chose it adjacent one. Suppose you have one, so here you can see. So this here octal is not possible because no adjacent 8 ones are there. Okay, octal is not possible. So here quad is possible. 4 adjacent one can create a one group. Okay. Now here this pair is also possible. Now this is not possible, individual one. Okay. Now we have a one here, right? So sorry. Suppose we have a one here. Okay, diagonal pair is not possible. Okay, so how can you choose this one for pairing? Okay, so this is the outermost column. Okay, outermost column or outermost row also can create a pair. So this column and this column, these two columns are considered as a adjacent one. Okay, adjacent column. So this one and this one can create the pair. Okay, this one and this one can create the pair. Okay, diagonal pair is not possible, and if you have the logic one in outer column, okay, you can create a adjacent pair. Okay, so here you can see, so first you have to check maximum possible octal, then maximum possible quad, then maximum possible pair. So if any single individual one is remaining, so we can, this one can create an individual group. Okay, so here, so in this expression, now I have to group this one, and this one is not can pair with the other one. Okay, this is the individual one. Okay, now I have to write the minimize function. Okay, now here, so if this single one can create one pair. This is means this is only singles. This one contains only single cell. For writing the expression, I have to check this value as well as this value also. Okay, so for this cell, here A prime, I have to write A prime. So for this cell, corresponding this value is A prime. Corresponding to this cell, B prime C is there. Okay, now come to this group. Okay, now in this both cell, which value is constant, that I have to check from this side as well as from this side. Okay, in these two cells, which value is constant from this side and from this side. Okay, now here you can see A is constant for this, so A is not changing for these two cells, so A I can write. Now I am checking this vertical value. Here you can see, So if you go from this cell to this cell, C is changed to C prime, but B is remain constant. So I can write B. Which value is constant, that I have to write. So for adding individual groups, I have to put a plus. If I want to include this value with this value, I have to put multiplication. Okay, if you want to include this value with this value, I have to put multiplication. And if you want to add all the groups, if you want to include all the groups in a function, I have to put plus sign, right? So now I will show you one example by using 4 variable. Okay, by using 4 variable. So f is f within bracket a, b, c, d, summation like these functions are given. Okay, this is in the SOP form. So I am drawing the KML. Here also I am drawing the KML. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, that means I have to put logic 1 in these cells. Okay, here I am putting logic 1 in these cells. Okay, now here, so first I have to check octal is possible or not. All adjacent 8 are, all adjacent 8 ones are there or not. Okay, so you cannot see 8 ones. Now I have to check quad is possible or not. Adjacent one should create a quad, means 4 adjacent 1. Okay, 4 adjacent 1 is also not there. 4 ones are there, but this is not creating the quad. Okay, then again quad is not possible. Now come to the pair. Pair is possible. You can see adjacent to ones are there. This can create a one pair. Also, this can create a one pair. So now question is like that. So these two one also can create a pair. But I will not consider this pair because the one is also included with in this group. This one is also included in this group. Okay. So these two one is not required to consider. Okay, so then these two ones are remaining. These two one can create a pair. Okay, now for these two cell, I am first selecting this one. For these two cell, I have to check this value. Okay, so a prime b is constant for these two cells. So a prime b. If you check this value, c prime is constant. Okay, c prime is the constant. D is changing. Now I am coming to the this group. Okay, here also you can see this value is same, AB. If you check this value, D is constant, C is changing. Okay, A, B, D. Now come to the this one. Here also you can see, if you see this value for these two cells, you can see A prime, B prime is constant. If you see the vertical value, C is the constant. Okay, this is the, so now you can see 2, 3, 4, 5, 13. From the 16 midterms you are getting only, from the 6 midterms you are getting 3 midterms. So you can minimize the expression by using KML. Okay, suppose, so such kind of the function is there. Okay, in this function, here it is also 1, here it is also 1. Okay. This 3, 13, 15, 4, 5. Okay. Here it is also 1, here it is also 1, here it is also 1, here it is also 1. Okay, now how we'll do? First I will check whether quad is possible. So in as one function is there, according to one function I am putting logic 1 in those cells. Okay, so first I have to check octal is possible or not. You can see octal is not possible, so quad is possible from these 4 cells. Okay, so apart from this quad, any more quad is possible or not? Yes, possible, because the outer column also can be considered as a adjacent column. Okay, so these two 1 and these two 1 can create a one pair. Okay, now come to the these two 1. Okay, so this two 1 also can create pair, and this one is left, this one also can create a pair. Okay, so what will be the function for quad? First I am writing. First I am considering this quad. Okay, so that means in this quad, for this cell 9, 11, 13, 15 cells are presented. So I have to check these two value. Okay, I have to check because these two value includes in these cells. Okay, so among between these two cells, I have to check which value is constant. You can see A is constant for these two cells. So A. Okay, now I am checking this value. So for these two cells, I am checking these two value. You can see D is constant. Now I come to the this quad. Okay, that means this cell, this row I have to check. So if you see this row and this row, you can see, observe these two value, B prime is constant. Okay, because these two cells include this corresponding row, this corresponding row. Okay, so from here B prime will come. From the vertical value, which value will come? D. Okay, D will come. Now this is already I have discussed for this cell A prime, B, C prime. For this cell A prime, B prime, C. A prime, B prime, C. Okay. So in this way you can minimize the expression. And there are lots of example. We can give lots of example. We can show the lots of example. Okay. So if anything is there, any kind of the position variable functions are there, you can minimize like this way. Okay. Suppose you have one like this way, one like this way, you can also create a octal. Okay, you can also create a octal. Okay, so from this all the values are changing. If you want to create a function for these adjacent 8 cell, you can see, if you see these value all are changing continuously. Okay, now if you check this value and this value. Okay, if you check this value and this value, now only D prime is constant. So for corresponding these 8 cell, okay, these 8 cell, if you create a one group, you will get only D prime. Okay, so in this way we can minimize the SOP expression by using the K-map. Okay, so next class I will discuss how can you minimize the POS expression using K-map. So almost same procedure, but some representations are different. Okay, I hope you you have understood all the things. Okay, so please like, share and subscribe my channel. Thank you.